All right, this is part A of our Unit 4 review. Question number 1, we're going to describe the translation in 3 different ways. So remember that we start at the pre-image, which is the one that does not have the prime. So we're going to start at triangle ABC, and we're going to have to translate to this triangle A prime, B prime, C prime. So I'm going to look at how do I move from this point A to this point A prime. And the boxes are small, it's kind of hard to see, but I know I'm moving from A to A prime. I'm going to move to the right, and I'm going to move down. So I'm going to have to count some boxes. How do I move right from A and down to get to A prime? So it looks like I move right 1, 2, 3, 4. Looks like I move right 4. And down 1, 2, 3, 4, 5, 6, 7, 8, 9. So again, the boxes are really hard to see, but if we're careful, we can count that we move right 4 and down 9. So I'm going to write that in words, and then I'm also going to write using my notation for translations here, my little vector component form. I moved right 4, so that was a positive 4, and I moved down 9, so it was a negative 9. Okay. And then also my transformation rule over here would say that I took every x value and I added 4, because I went to the right 4, and I took every y value and I subtracted 9, because I went down 9. So there's 3 ways to explain that translation. In words, with my vector component, and with my translation rule. Cool. On the next one, we have a composition, which means more than one transformation. So we're going to start at ABC. So find the one that does not have the primes, triangle ABC. And our very first transformation is that we took ABC and we reflected it to get A prime, B prime, C prime. So the very first thing was a reflection, and we reflected over this x-axis right here. All right, then after we did the reflection, we took this triangle, A prime, B prime, C prime, and we shifted it to the right and up. I'm using B prime and B double prime as an example because it was just easy to see. So the first thing we did was a reflection over the x-axis. And the second thing we did was a translation. And I shifted, let's see, we use B prime as an example, right? 1, 2, 3, 4, 5, 6. And up 1, 2. All right, so I don't really like the way this question was worded because it's kind of backwards. It says a translation blank units to the blank. So it was a translation that was 6 units to the right and 2 units up. After A, so this was the first thing that we did, was the reflection over the x-axis. So I don't really like the way they worded it because it's kind of backwards, but we figured it out on our own over here. So the way we did that was we started with the one that did not have the primes, and we saw that it was flipped over the x-axis to give us this second triangle. Now from that second triangle, I had to pick a point and count. So I picked B prime and counted over 1, 2, 3, 4, 5, 6, and then up 1, 2 to get to its corresponding point. I could have used any point. B just seemed like the easiest one. Number 3 says rewrite the following composition as a single transformation. So this is like me saying, hey, take 5 steps to the right and then go back 4 steps to the left. If I did that, I would only really be taking 1 step to the right. And then if I said, hey, go 2 units down and then go 2 more units down, I really went 4 units down. So that's one way to say it. Or you could just add them up. You could just say positive 5 minus 4 is 1, and negative 2 plus negative 2 is negative 4. So there's a couple different ways you could say it. But that's what we're looking for. On number 4, it's a reflection over the line y equals negative x. So the first thing we need to do is draw the line y equals negative x. Remember, it's going to start at the origin, and it's going to go down 1, right 1. Because it's negative, it's going to go down 1, right 1, down 1, right 1. And I keep that going over here as well. Not the greatest line ever. And it's really small. All right, so what we do with the reflection is we count how many units it is to that line of reflection and make a mirror image on the other side. Well, since this is a diagonal line, instead of just counting, I'm going to count the diagonals. So since J is 1 diagonal, 2 diagonals from the line, I'm going to count 1, 2 diagonals on the other side. And we'll call it J prime. That's what we'll do for each point. Look at L. 1, 2, 3, 4, 5, 6, 6.5 diagonals. So we'll go 1, or sorry, that's a half. So half, 1.5, 2.5, 3.5, 4.5, 5.5, 6.5 diagonals on the other side. Call it L prime. Same thing with K. 1, 2, 3, 4, 5, 5.5. Half, 1.5, 2.5, 3.5, 4.5, 5.5. K prime. All right, and that should look like a nice mirror image. Cool, looks good. And the coordinates for those points, my coordinates for J prime look like from the origin, I went left 3 and down 1, so negative 3, negative 1. K prime looks like a negative 7, negative 4. And L prime looks like a negative 5, negative 8. There is a rule for this. There is a shortcut. The shortcut is we take whatever x and y we had originally and we switch them. And make them negative. Or make them the opposite of what they originally were. Okay? So that is the rule, if you like rules. I know some teachers teach that, and I used to make my kids memorize them, but that's the rule for y equals negative x. If we had y equals positive x, so if we had a reflection, I would use a reflection, R for reflection, over y equals positive x. The rule for that one any xy would just become y comma x. So if you like rules, you can memorize those rules for y equals negative x. Okay, y equals negative x uses this rule. And then y equals positive x uses the one in blue. All right, last one here. If point D is reflected across the y-axis, what are the coordinates D prime? So let's first identify D. Now let's find the y-axis. So the y-axis, y-axis, y-axis. All right. So we're going to reflect that. So we're going to make a mirror image. So since D is 1, 2 units away, we're going to put D prime 1, 2 units on the other side. Cool. So D prime will go right there, equidistant to that line. So the new coordinates would be -2, 3. Part B says, what are the coordinates of J prime if J is rotated 270 degrees around the origin? All right, so this is the one where I would ask you to turn your paper. So I'll find point D, and I would turn my paper 270 degrees counterclockwise. So I'm going to go ahead and do that with my iPad here. So that's going to be 270 degrees, means 3 turns. Okay, so when I do that, a 1, a 2, a 3, I see that J prime is going to be in the 3rd quadrant. Whenever I turn my iPad 3 turns, J prime ended up right here. Okay, so and the coordinates for that look a little something like that after I turned it. So my coordinates were -2, -1. So we turn our paper and then we just look at whatever the new coordinates are. So after turning my paper, J prime ended up right here. What are the coordinates of J prime if J is reflected across the line y equals x? The line y equals x, again, is a diagonal line with a slope of 1. So I'm going up 1, right 1, up 1, right 1. Keep going down 1, left 1, down 1, left 1. Cool, and we're going to flip J over that line. So J is 1 diagonal and a half from that line. So on the other side, we're going to go a half and a 1. And that's where we'll put J prime, another J prime. They could have been a little more creative with the points. And that's at -2, +1. All right, number D says if L is translated. So I'm going to take point L and I'm going to translate it. And this rule tells me to move right 6 and down 7. So from L, I'm going to go right 1, 2, 3, 4, 5, 6, and down 1, 2, 3, 4, 5, 6, 7. Let's be right there above G. Okay, so the coordinates of that are -2, -2. All right, part E, what are the coordinates of M prime if M is rotated 90 degrees? So 90 degrees means 1 turn counterclockwise. So let's find M. Let's turn my thing 1 turn. All right, when I do that, my new coordinates, I still got my iPad turned. My new coordinates are it looks like right 1, 2, 3, 4, 5, right 5, and up 1, 2, 3, 4, 5, 6, 7, 8. Right 5 and up 8. I'm just showing you what I saw when I turned my paper. And last up, if H prime is the point -5, 2. -5, 2. What is the line over which it was reflected? That's a cool question. You see the original H, hi, and then the new H prime. So we need to see what's directly between the two, the middle of H and H prime, and that's the line that they got flipped over. So let's do some counting. Let's see, 1, 2, 3, 4, 5, 6. So there's 6 units between the two. So let's go 3, 1, 2, 3, and that's got to be the middle. So that's the line that they were flipped over. And that line goes through the y-axis at 1, 2, 3, 4, 5. That line cuts through the y-axis at 5.